Welcome class. This is our Unit 1 Formative 2 Day 5 video on equations with variables on both sides. Now before we get started, there are three things that can happen when you solve these equations. One of them is an identity. And what an identity is if your final result in the process of solving an equation, you get, for example, 4 equals 4, which that's a true statement, okay? So if that's a true statement, it's an identity. Another thing you could think of it is as mathematicians sometimes like to use is all real numbers. So either one of those is correct for this case. Well, now another thing that could happen is if we have a no solution. So on a no solution, that is if you have something like 3 equals -2. Well, 3 equals -2 is a false statement. So because it's false, it's no solution. And of course, our last thing that can happen is if you have a solution, like all of our other equations. And of course, that's just if it's like x equals 0, for instance. So those are the three possible cases that can happen. On our first example here, just notice that we have two terms with a variable on both sides of the equation. So let me just draw my line here. I want to determine which is the smaller variable term and move it to the other side. So 3n is the smallest, so I'm just going to subtract 3n because it's positive. If you want, you could throw that positive in there so you know what to do with it. That 3n's cancel there, so just drop your -5 here, and then we just calculate the right side. 7 minus 3, that would be 4n plus 11 there. All right, now it's just a typical two-step equation. We're going to subtract our 11 because that's addition. So go ahead and do that. So you know, if you got two negative numbers, that's kind of like owing money. If you owe $5 and owe 11 more dollars, you're going to all together owe $16. So it's -16 or -16 equals 4n. And then we finally undo multiplication by dividing by 4. -16 divided by 4 is -4. So n equals -4. So on this next example, I just want you to kind of notice our two n terms. They're both negative. Honestly, if you wanted to, you could cross them out right now since they're both the same type of n. However, I like to just move one of them, okay? So I'm just going to move the right one here. Since it's negative, you add an n to both sides, and our n's cancel. So again, make sure you drop the -24. Don't forget that negative. And then also drop our 5. So we have -24 equals 5. Well, that's one of our cases that we talked about. This is a false statement. So that means this equation has no solution. Our third example here, if you notice, we have a lot of parentheses. So we first want to get rid of the parentheses. And that just means we have to distribute. So on our left side, we have to distribute a 2. We have 2x plus 12. Remember that distributing means to multiply. So if you want, you could put the dot there to show multiplication. We have a negative on the right side in front. That's kind of like -1. And now we distribute the -1. And again, that means multiplication. So -1 times 4x is -4x. -1 times -36 is +36. And now it's kind of like one of the equations we've previously done. So because I want to work with positive numbers, I'm going to take my -4x and add the 4x to the left. So then we have 2x and 4x. That gives me 6x. Drop our 12. So 6x plus 12. And then we're left with a positive 36 on the right. So next we want to get rid of our 12 since it's addition. Addition comes before multiplication when we want to undo operations or finding inverse operations. So we're going to subtract the 12. 36 minus 12 is 24. And we just drop our 6x. And finally, we divide by 6. So x equals 4. On our fourth equation here, we got a decimal out in front. So again, we have to distribute the 2.5 first to get rid of our parentheses. So 2.5 times 4, if you think of it, 2.5, okay, it's kind of like a quarter. If you have 4 quarters, that means you get $1. So if you have 2.5 times 4, we get 10. So we get 10x. 2.5 times -4, that is -10. If you notice on the right, we have a 2 and a -12. 2 and a -12, that gives us a -10. Don't forget your 10x. If you want to put that in front, that would be great. And now, here, if you kind of notice something, our left and right sides are the same. So you could kind of jump to the end and make the conclusion that this is an identity. If you want, go ahead and subtract your 10x first to get the variables gone, and then just drop our -10s to show that that's an identity as well. So again, this is an identity because it is a true statement. And finally, we have one more here. We have to distribute once more. We're going to look at this 4 here. 4 to a -5 and 4 to a 3g. We're not going to do anything with this 5g first, so just drop it down. 5g plus a -20. So I didn't mean to put the plus sign there, but -20. And then 4 and a 3g is plus 12g. We haven't done anything with the 1 minus g yet. So we have some like terms here we have to combine. We have to combine the like terms first before we move anything. So a 5g and a 12g, that is 17g. We have this plus a -20, that just means -20. Again, just drop your right side. So now we can move our variables. And again, I want to make a positive g out of this. So that -g on the right, we're going to want to move it. We're going to add a g. Again, that's negative 1g, so we can add 1g. 17 plus 1 is 18. 18g. Drop your 20. Do not leave the negative. It is a minus 20. Those g's are gone, and we're just left with a 1 on the right side. So let's just finish this off here. We're going to add 20 on both sides since that was a negative 20. So we're left with 18g equals 1 and 20 is 21. And finally, our last step is to divide by 18. So when we divide by 18, g equals the fraction 21 over 18. However, if you notice, they're both divisible by 3, so we can reduce this fraction. If you divide both by 3, we should get 7 over 6 as our answer. Okay, these are kind of tough, so if you want, you can rewatch the video again. Otherwise, we'll just see you tomorrow.